Let me introduce myself. I'm Bob White. I'm Associate Director with Dennis of the Faraday Institute, so I can add my welcome to all of you. It's really good to see you here. And I'm going to introduce John Pilbrow to give the first of two talks, one today and one tomorrow. You can read about him in the pack of material you've got. All sorts of very distinguished things he's done. But the thing that struck my mind was that he's been working, for one thing, in applying science to medical issues, which is an incredibly fruitful thing to do. And I think if I had my time again, I might not have become a geophysicist, I might have become a medical scientist, actually. So it's great to see that you've been able to do that in the course of your normal career. But he also has an interest, he's a Christian, he's a scientist, and he has an interest in bringing those together. And I think that's what you're going to talk about both today and tomorrow. So starting today with Einstein and the impact of his views on our views of divine action. I think there's a sort of summary of it. Anyway, over to you, John.
Thank you. Well, you've got the title there and you've got the abstract, so I can skip the first. I think you've all got printed copies of the abstract. First of all, a very big thank you to both Dennis and Rodney for making it possible for me to be here. It happened when Dennis realised I was going to be in Oxford during this past week, and he emailed and said, well, of course, do you realise we've got a Faraday Institute course? I passed your name on to Rodney, and within 5 minutes there was an email from Rodney, oh, could you come, what would you like to talk about? So I suggested two topics. This one I had given before in a different context, although it's been rewritten a bit for this particular meeting, and the other one I hadn't written, and I'll explain tomorrow that there were times when I had second thoughts about picking such a difficult topic. I'm aware that those of you attending this course are mainly involved in secondary education as teachers of science, religion, philosophy and so on, and that I cannot necessarily assume that you all have a scientific background. Knowing very little about the syllabuses you teach, the nature of your students and the backgrounds you bring to this weekend may put me at something of a disadvantage, as I come from a part of the world where the later years of schooling are managed rather differently. However, a perspective from down under may offer its own challenge. I'm sure I will raise a lot of issues that will relate to some of the questions your teenage students may be concerned about. I shall be speaking both now and tomorrow morning, from within a Christian framework. Some of you here may not necessarily share that viewpoint, but I hope that I can raise issues and suggest ways of thinking that you will also find helpful to you. I noticed in the Ashgate leaflet, the last book listed is called God, Life and the Cosmos, Christian and Islamic Perspectives. I had the task of reviewing that a couple of years ago, and I'm not going to talk about it today, but I'd just like to say it's been a very helpful tool in my discussions with a couple of Islamic friends who are physicists and now living in Melbourne. Both of my talks this weekend will take us into territory not addressed in classical theology, nor indeed, I suspect, in much contemporary theology. 2005 was the World Year of Physics, a year of celebration in honour of Einstein's 4 groundbreaking papers published in 1905, and also of his crowning achievement, General Relativity, published in 1915. In the light of the extraordinary influence of relativity on science in the 20th century, in 1990 Arthur Peacock wrote this: relativity theory in its special and general forms, and even more iconoclastically quantum theory, together caused a complete revolution in human understanding of the physical world, the consequences of which are still to be absorbed into philosophy and hardly yet into theology. What I shall attempt today is to indicate the extent to which a representative collection of Christian writers, theologians, scientists, and scientist theologians, of which there are now a good many these days, the extent to which these have incorporated Einstein's relativity into their thinking. I've sought, therefore, to identify those who addressed relativity in a consistent manner, and secondly, to see how relativity impacted on their thinking, if at all. Over the past generation, T.F. Torrance, more than most theologians, has sought to champion Einstein's views, and this is widely acknowledged. On closer inspection, it appears that Torrance focused more on Einstein's religious views and his philosophy of science than on how specific ideas from relativity might be applied to theology. Actually, Torrance's greater contribution may well be seeking to put theology on the same footing as science, subject to the same level of intellectual rigour of proof, internal consistency and verifiability, what he calls theological science. It's noteworthy that Alistair McGrath, who will actually come later in the year to our ISCAS conference in Australia, follows Torrance in this respect. Torrance is also well known for his emphasis on contingency that I won't refer to again. I made what for me was an important discovery when preparing an earlier version of this particular lecture for our conference in Canberra 2 years ago. I found that on the whole, relativity took a back seat compared with topics such as divine action, creatio ex nihilo, creatio continua, contingency, evolution, and necessary rebuttals of the God of the gaps. Regarding God and time, St. Augustine was frequently mentioned, so it's perhaps not surprising that I decided to follow up divine action, which is my topic tomorrow morning. I also discovered our topic is not new. I came across an article on the internet entitled Relativity and Christian Thought by J.W. Haas, a physics professor in the United States, which was an interesting historical analysis that exposed a love-hate relationship between theologians and relativity in the 1920s and 1930s. It will be helpful and necessary to identify categories for our discussion: theological, philosophical, metaphysical and scientific. And I've given some simple definitions, I think some of which I took from the Oxford English Dictionary, and I just draw your attention to something John Taylor tabled just a little while ago, and you can look at his definitions of philosophy and some of the other things on the back, on the two of which will be relevant tomorrow. Theology is about God, his nature and relationship to mankind and the universe. Metaphysics is concerned with application of first principles. And I will tend to use that term because the writers I'm referring to today and tomorrow tended to use that term on the whole rather than philosophy. Philosophy is the pursuit of wisdom or knowledge of things and their causes. Science is based on experimental method, development of hypotheses, and theories with predictive capacity, and of course much more. In today's talk, and indeed tomorrow's, I will make very little distinction between philosophy and metaphysics, and some amongst you might want to debate that. I shall not discuss relativism in the social sciences, a 20th century social construct that parallels 19th century evolutionism. Both relativism and evolutionism lie in the category of metaphysical, but that does not stop proponents from claiming sometimes that they're scientific. Today I shall attempt a fairly non-technical introduction to both special and general forms of relativity before looking at the points of contact with theology. To achieve my goal, it will be necessary to use a good many quotations from the authors I've looked at, so that you will be able to appreciate the points that have been expressed in sufficient detail for me to make my case and for you to reach your own conclusions. So my purpose of my lecture, just to reiterate that, is to identify those writers who addressed relativity in a consistent manner and to see how relativity impacted on their thinking, if at all. I hasten to point out I'm not a relativity theorist but a spectroscopist. Although I taught special relativity many times and also relativistic quantum mechanics in the context of teaching advanced quantum mechanics, I did not get the opportunity to teach general relativity. You see, we had a specialist in our department who provided all the teaching in that area, but I'm grateful for lectures to staff and students that he presented to us from time to time. Throughout my research career, not a day has passed in which I have been unaware of one of the important consequences of relativistic quantum theory, something called spin-orbit coupling. This impacts directly on the key parameters measured in electron paramagnetic resonance of paramagnetic ions and solids in organic molecules and metalloproteins. Introductions to relativity in the context of Christian theology range from the fairly technical, Chris Isham in the book edited by Bob Russell, Stoger and Coyne in 1998, to very readable accounts by one Professor Ambrose, a retired biochemistry professor, and Eric Maskell, originally trained as a mathematician. The references that I think you've been given contain accounts, some level of accounts of relativity in each case. The fundamental assumptions of special relativity are really two, and the first of these is that the speed of light in vacuo is constant. This imposes the stringent condition that information cannot be transmitted faster than the speed of light. And we'll have occasion to refer to that again. Also foundational is the invariance of physical laws in all inertial frames. I'll explain what they are in a moment. It means that physical laws, Newton's laws for example, have the same form whether I'm standing here or I'm riding the car up the road there at a constant speed relative to this room. Inertial frames of reference then are those that move with a constant relative speed. And special relativity requires that we must abandon classical notions of simultaneity and the container model of space. So, an event that's judged simultaneous, say in this room, to an observer moving very fast at a constant speed relative to us would not consider those two things simultaneous. An immediate consequence of special relativity is that we need to talk in terms of four-dimensional space-time, where time is introduced on a more or less equal footing with the three space dimensions. It will be pretty obvious to you that these foundational ideas in relativity are counterintuitive. That is, we do not arrive at them using our everyday intuition, which is located in the world of classical physics, which is quite adequate when Dennis rides his bicycle here in the morning, or Bob may have come in his car this afternoon. I don't know whether he rode a bicycle or not. So for everyday things, the rules of classical physics work perfectly well for us. But let me just point out that there are many counterintuitive ideas found in religious thinking, and in Christianity in particular. Love and forgiveness, I suggest to you, are really counterintuitive concepts. The laws of physics are connected in special relativity by means of the Lorentz transformations. And don't be bothered by the fact I've thrown in 3 or 4 equations in this talk. They're relatively simple ones, and they connect what's happening in one frame of reference, namely here, with the one that's moving at a speed v relative to it along the x-axis. And the interesting thing is you've got this factor in the bottom, the square root of 1 minus the speed divided by the speed of light all squared. And you can see that if v equals c, the denominator is going to be 0, and you probably remember from your high school mathematics that that's going to cause an infinity. But of course things don't get to that stage for material objects. Time is connected by a slightly more complicated relationship. I don't intend to go into that. And the only point of showing these equations is that they're relatively straightforward. And they enable observers in 2 different frames of reference to connect their experience with each other. Einstein, of course, became a 20th century phenomenon, and the famous picture of Albert with his hair flowing all directions ended up in a lot of undergraduates' rooms over a period probably of 50 years or so. Now, while he captured the popular imagination, his theories came a close second. Special relativity has produced some bizarre sounding outcomes, and I've got to flip through this slide quickly and go to the next one, and I'll go back. What are some of these? Moving clocks run slow. So a clock moving on that axis system to the right of that previous diagram, if it's going fast enough, would really show a very different measure of time for the same events one was measuring here in this room. But there's no contradiction, because we can correlate our results here with what the other observer also finds. And interestingly, this particular effect has been well verified using the decay of mu mesons that come down in cosmic rays. Then there's the twin paradox. The twin who travels in the spaceship at near the speed of light would have aged less than his twin left on Earth when he gets back. But the paradox arises when seen from the vantage point of the twin who stays behind, because there would seem to be no preferred frame of reference. He too might expect to have aged less than the travelling twin. This has been debated on and off, and I believe it was solved by Einstein using general relativity later on. But just one thing to note is this one who goes out in the spaceship has to turn around and come back, so that breaks the symmetry. And it's also been tested with a 707 aircraft going right around the Earth, from the United States and back, with an atomic clock on board, and the time is measured on that atomic clock and compared with the atomic clock on the ground in the laboratory, and Einstein's special relativity was proved to be absolutely correct. There's the increase of mass with velocity. So moving objects get heavier, and this is confirmed in particle accelerators. It's confirmed in the cyclotron being built next to our campus in Melbourne, as the electrons that move around in the synchrotron ring are brought nearer and nearer the speed of light. And there's a limit, of course, beyond which you can't go, because you'd require more energy than you could produce with the whole electrical generation system in our state of Victoria. Then the most famous equation is E equals mc squared, the connection between energy and mass. And that's verified for chemical reactions. The most dramatic demonstration was of course seen in the first atomic bomb. And then along the same lines as the moving clocks run slow, you have length contraction. So an observer, if you were measuring an object going past you at a fairly rapid rate, you would say that it had shrunk in length, whereas the observer on board would say it was longer. Again, there's no contradiction, because different observers are able to correlate the results using the Lorentz transformations and the other equations that follow from this. Now I have to go back. Special relativity requires we must abandon classical notions of simultaneity and the container model of space. I mentioned that before. Theologian physicist Robert Russell has this to say: Einstein took the first step in establishing modern cosmology. Space and time are put on an equal footing, 4D space-time. With the new arena of space-time, our intuitive notions of the simultaneity of events are altered. Again, there's no real conflict, as the different observers can always, in principle, correlate their results with those in other inertial frames using the Lorentz transformations. And Russell, again, quoted in the book edited by Russell Stannard, before relativity, people regarded space and time as two distinct and unconnected entities. That's the assumption that still underpins how most of us live our day-to-day life, and perfectly right, we should do so. These issues become especially relevant within special relativity, really only at high speeds, close to the speed of light. Most of what we can do, we can send spacecraft to the moon, don't require relativity. Now, what about general relativity? General relativity makes the assumption, a basic assumption of what's called the principle of equivalence. That is, you can't tell the difference between whether an object is being accelerated or whether it's being acted on by a uniform gravitational field that has essentially the same strength. General relativity is a theory of gravitation. In classical physics, we learn that the gravitational force between two objects depends on the inverse square of the distance between them. And while in general relativity you can get that out as one particular solution in a given case, Einstein wrote his equation in this form. And I'm not going to go into this in any detail. It's just to show you that a relatively innocuous, simple-looking equation could have had such a profound effect on physics and on cosmology in the past century. So on the left, this quantity here, and the AB represents really represents 10 equations, what we've got here. That's to do with the particular a space-time model. Over here is to do with the arrangement of energy and matter and so on. And R is to do with the radius of curvature of space-time. So we move into something which has a rather different look or feel than even special relativity. At a technical level, Mr. Thorne and Wheeler have this to say: space tells matter how to move, matter tells space how to curve. And so we have a different way then of looking at what's happening in our world. But of course, the real issues resulting from general relativity only become very important when you're near some very, very massive object or in some complicated situation that you're modelling for cosmology. The link between space and time, space-time, and special relativity, and the important link between matter or mass and energy via E equals mc squared, might cause us to speculate that somehow space-time, matter and energy are all interconnected. This is indeed the case and is fundamental to general relativity, and the fourfold connection is intrinsic to Einstein's tensor equation that I just showed you. But none of this is obvious to us in our everyday world. I think this is the part of the lecture that Rodney Holder should be giving us, because I think his PhD involved general relativity. Now, general relativity is in fact a theory of gravity. And Bob Russell has this to say: Einstein took a radically new approach, whereas the space-time geometry of special relativity was flat, or pseudo-Euclidean, that's our ordinary geometry. In relativity theory, space-time is allowed to curve. And this is very hard for us to understand, even for me as a physicist. It explains many subtle effects in the cosmos, especially the three classical tests of general relativity. And these are so-called perihelion of Mercury. You get strange behaviour the way Mercury encircles the Sun, part of its life cycle. And Einstein predicted that there was a small correction that was ultimately measured. It's only 0.43 seconds of an arcsec per century, I think, but it has been done. Bending of light by the Sun. That experiment was actually done by astronomical observation down towards Hawaii in 1919 by Eddington on a special, I think, Royal Society project. And the gravitational redshifts of spectral lines, in addition to the redshift of light coming from distant galaxies, which is just to do with their motion and the fact that space is expanding, this additional effect was only measured much more recently, within the last 20 years or so. But general relativity has stood up precisely as Einstein predicted, although apparently he wasn't that impressed by those tests, as we heard yesterday from Dennis. So relativity constrains the way we need to think about space and time. In particular, it forces us to be clear about what are meant by time-like and space-like intervals. And Chris Isham, who's a physics professor from London, put it like this. We need to make a fundamental distinction between time-like and space-like intervals. In particular, 2 points in space-time are said to be space-like separated if it is impossible to send information from one to the other. 2 points in space-time are said to be time-like separated if it is possible to send information from one to the other. And I mentioned earlier when we talked about the speed of light that it is impossible for any information to be sent at faster than the speed of light. So that's a constraint that's fundamental to our universe. Since nothing can travel faster than light, it follows that whether a separation is space-like or time-like is determined ultimately by trajectories of light beams in curved space-time. Okay, that's getting a bit too detailed, and it's getting down to sort of the guts of the physics, and I don't want us to get bogged down in that, because I want to see what impact these things have had on Christian thinking. Just one last point about general relativity. It is not a quantum theory, at least it isn't yet. There's no adequate theory of what's called quantum gravity, which would allow the exchange of information at the speed of light, as is the case for photons of electromagnetic radiation. There are many large-scale gravity wave experiments set up, including a big one in Western Australia, but so far no one has reported the evidence for gravity waves. The sensitivity of these things has to be incredibly high. Just a few comments about what has been the impact of relativity on cosmology. Current cosmological models all depend on general relativity. Big Bang cosmology requires not only general relativity, but particle physics, nuclear physics, thermodynamics, and much besides. The picture that emerges from Big Bang cosmology confirms the experimentally determined age of the universe of 13.7 billion years. That age is deduced from the so-called Hubble constant, which is the ratio of distances of galaxies and the recession velocities determined from redshifted light that applies to all the galaxies we can observe. The picture is of a universe that has expanded to its present state from the hot Big Bang, whose physics is well understood back to the time of element formation and speculative at earlier times earlier than that. That's in the book on the Moral Nature of the Universe by Nancy Murphy and George Ellis. But what's actually interesting in that book, George Ellis is of course a leading cosmologist, but there's very little reference other than this to relativity, either special or general, in that book, because their concern was to think about broader issues such as ethics. General relativity accounts for the expansion of the universe. In fact, the universe is still expanding, and it's space that's expanding. It's important to realise that galaxies are not moving to already existent space, but the outermost ones that we can see are at our so-called event horizon. And just in passing, nothing meaningful can be said about time shorter than the so-called Planck time, which is 10 to the minus 43. Imagine 1 over 10 with 43 noughts following it. And you might think that it's not a very sensible sort of a time, but it's a very fundamental time in the theory. We don't know what the laws of physics are for between time 0 and that particular time. And just a little quote from, oh, so this one as well. I put this one in because this is by a retired biochemistry professor who obviously read carefully. The universe expands not because the galaxies are moving, but because space is expanding, and that's the current view. And then there's a question of when did time begin? The current view is that when the world was not, there was no time. Augustine reached a similar conclusion 1500 years before Einstein. And Dennis mentioned, I think, referred to that yesterday. Although it's common to talk of t equals 0 as the beginning of the universe, and because we're limited in our present understanding of physics to times longer than the Planck time, we can say nothing very meaningful about the very short times, the very, very early stage of the universe. There's another aspect to the role of time, rather metaphysical in nature, which is, it is one of the great discoveries of this century that the universe itself has a history and partakes of becoming. Quite apart from whether the universe as a whole will continue to expand forever or eventually begin to contract, our own local powerhouse, the Sun, has a projected life of maybe another 7 billion years or so. But before that is reached, it will first become a red giant, and expand to encompass the Earth and other planets. So life as we know it on this planet does not have a long-term future. And this consideration leads naturally to the question, does the universe have an eschatological purpose? That's Bob Russell. Ted Peters responds by saying Big Bang cosmology opened the window within science toward transcendent creation in the past, while apparently closing the window to redemptive eschatology for the distant future. And just to pursue that quote, in the standard Big Bang model, there is no everlasting future to intelligent living beings or even to the laws of nature as we know them. Whether fried or frozen, all life will end. There is only curved space-time dimension. And at one level, that's pretty scary. A year ago, my wife and I had the privilege of attending a conference on eschatology in Canberra, where the keynote speakers were Bishop Tom Wright from Durham, who admitted he knew nothing about science, Bob Russell and Ted Peters, where all these sorts of issues were discussed over a 2-day period. And I haven't time to go into them in any detail. There is not time today to consider in detail the existence of an arrow of time. This is implied by Big Bang cosmology, irreversible thermodynamics, and our own physiological, psychological experience of time. For our purpose today, I take as read the existence of an arrow of time. Now I want to move on to ask the question about the impact of relativity on Christian theology. Scientist turned theologian Alistair McGrath notes, one of the most dramatic changes in recent scientific culture has been Einstein's theory of relativity. Yet many theologians were unwise enough to assume that Newton's ideas were permanent features of the intellectual landscape and based their theologies upon them. McGrath's comments are a warning that we must seek to present our ideas, whether theological or otherwise, in terms of well-established paradigms, even though they may be rather different from those held in the past. None of us can anticipate the shape of new paradigms yet to be discovered, if any. And we're faced with doing the best job with what we presently know. That has always been the case. It remains so today. The indication from Big Bang cosmology of a beginning to the universe raises the question as to whether it is consistent with a Christian understanding of creation, or even an Islamic or a Jewish one for that matter. To quote McGrath again, it's now widely agreed that the observable universe had a beginning, yet that brief statement may well be judged to raise far more questions than it answers, deeply religious questions which are raised by modern cosmology. So I think you would judge there hasn't been a rush to say Big Bang cosmology exactly matches our understanding of creation in time as talked about in the Bible, for example. I've mentioned Torrance before. I think that a couple of statements from him are worth noting as well. He says we need to rethink the essential basis of Christian theology in the relation of the incarnation to space-time, and to think completely away the damaging effects of a deistic relation between God and the universe. This raises some other questions, but I think the main point is fairly clear. And then he goes on to say, any attempt to explicate knowledge of God outside of or apart from those structures of space and time that God created is inevitably and essentially irrational. It is only from within the universe and through the medium of its contingent realities that we may articulate the knowledge God gives of himself. What this means is that any credible theology cannot ignore the impact of modern paradigms, whether relativity or others, any more than it could have resisted the Copernican revolution 4 centuries ago. My friend Mark Worthing in Adelaide, who's an American but is a Lutheran theologian, came out many years ago, has this to say. By 1921 it was clear that Einstein's theories were making a significant impact in the fields of philosophy and theology. Relativity has made it impossible to think in terms of absolute time and subsequently in terms of simultaneous or sequential events as we did before. It turns out, however, that I think his first statement is probably certainly at odds with the quote from Arthur Peacock I had at the beginning, and almost everything else I've read. Not so much the sense of a love-hate relationship, which apparently was the case in the 1920s. But I'll come back to that in my conclusion. The most pessimistic comment I found regarding the relevance of relativity to theology or to Christianity was due to Chris Isham. It says, what can these new scientific ideas on creation contribute to the theological archive of metaphysical wisdom? I suspect that the honest answer is not very much. But it's sometimes worth finding out what people say 10 or 15 years later, and I think in this later statement at the bottom, his ground may have shifted a little. He says, I think that is relativity is relevant. It's an interesting question how you conceive of the existence of time if you're a physicist. Clearly, our own human experiences are that tomorrow hasn't yet come and yesterday's gone. But the mathematics of physics is quite different. If you look at the mathematics of Einstein's theory, you find that you're presented with a thing called the space-time continuum. And then he goes on to say, insofar as God does know in the ordinary sense, he does indeed know the whole of reality, past, present, and future. So here's another quotation which is to some extent challenged by others. That is, the implication that God knows past and present as well as the unformed future is challenged by others, and I shall come back to that in a few minutes. Theologians raise the question as to what extent theology should allow itself to be too closely linked to any particular scientific paradigm. In particular, it's thought dangerous to try to link our theology too closely to any particular cosmological model, such as the Big Bang. In the same way, others caution that we should not attempt to constrain biblical chronology into a scientific chronology, something that applies equally to creation narratives and eschatology. In particular, regarding Genesis 1 to chapter 2, verse 4a, and Big Bang cosmology with t equals 0, Bob Russell, John Polkinghorne, Ted Peters and many others caution against trying to find the wrong kinds of links. Put another way, Murphy and Ellis in their book note that people repeatedly try to extend the conclusions of physical cosmology to areas it cannot handle. This to some extent may be to do with categories that I mentioned at the beginning, but that's going to be more important in tomorrow's talk. More plausible misconceptions have also repeatedly clouded the discussion. These are the use of Big Bang theory in Christian apologetics and the corollaries of this argument. The idea that either the steady state theory or the Hartle-Hawking no boundary proposal leave no role for God. These arise from confusion of the scientific idea of a beginning with the concept of ultimate causality. This is a very important point that goes somewhat beyond today's talk. The category error seems to me to be that of confusing the idea of t equals 0 from Big Bang cosmology, a scientific conclusion, with philosophical and metaphysical ideas of ultimate causation. And Murphy and Ellis, I guess this is George Ellis writing, says a priori any of the possible ultimate causes could be compatible with any of the modes of realization of a physical universe. In essence, this truth has been known since the time of St. Augustine. This qualification does not mean, in terms of ultimate causation or metaphysics, nothing can be gained from cosmological studies. Or Mark Worthing, in commenting on the same sort of issue, says, while many physicists at least initially seemed uncomfortable with the Big Bang, not a few theologians found in the emerging view of a non-static universe with a seemingly definite beginning a greater compatibility with the idea of a creator God who providentially governs the world. And I found the next quote I hadn't, it's just a quote from John Polkinghorne, where he says somewhere that theology could have lived with either Big Bang or steady state theory, because our theology ultimately will be based on an understanding of causation, ultimate causation, not on a particular model, however good Big Bang cosmology is as a paradigm. What all this amounts to is that we need to be clear that we're not confusing categories. For example, Polkinghorne's claim that theology could live with either Big Bang or steady state cosmology is, I believe, a metaphysical statement. The arguments I've given a few minutes ago regarding linking creation with the Big Bang, because it appears to imply t equals naught, raises the question as to the extent to which we can rely on apparent coherence between theological, metaphysical, philosophical and scientific accounts of the same reality as presently understood. Now a few comments about God and time and God's foreknowledge. And here I turn to John Horton, I think is well known here. I think he's on the board of the Faraday Institute. Theologians and philosophers of a century struggled with the problem of how God is related to time. They have differentiated between God outside time and God within time. And further he says, scientific thinking since Einstein has recognized that time is relative in the sense that it can be different for different observers. None of that has removed the vital difference between before and after in any given framework, or the reality of cause preceding effect. And that last statement, I think, is particularly important. I'll just digest that in a minute. I'll fix my papers. That God has to interact with time is accepted, though there are differing views as to what this means. We would imagine that God's temporality will in no way be affected by the ultimate demise of the earth, or even of the universe as a whole, as understood by modern cosmology. I do, however, reject panentheistic views of God's immanence, whereby God would be diminished in any future demise, even of the earth. And Eric Maskell, a theologian from a former generation, originally trained as a mathematician, I believe, he says, even when we describe creation as a continuous act of God, this does not mean that God himself is in time. Time is the condition of existence of creatures, not of God. While God is not in time as we are, there must be a temporal aspect to God in order for him to interact with and in the world. Nevertheless, we need to be reminded that we are the creatures. Wolfhard Pannenberg, a German theologian, present day, very keen to promote dialogue between theology and science, comments that absolute space and absolute time, which the theory of relativity denies, were no longer the absolute space and absolute time of Newton, conceived as the expression of the presence of God in creation. That's just a different way of saying the same thing, but I think it was worth including. So Pannenberg is really pointing to the demise of the so-called container model of the universe, in which space was assumed to pre-exist and also thought to be eternal. Now one or two comments about God's foreknowledge. Philosopher-theologian Nancy Murphy has this to say: I don't think that the changes in science made much difference to our view of God's foreknowledge. We've always claimed that God is in some sense outside of time or beyond time. God is in some sense present to the whole of time, however we describe that in physical terms. I think this is a philosophical statement and not particularly dependent on relativity. Bob Russell, with his physics background and implied consideration of reality, offers a compelling insight into God's foreknowledge, where he says, a traditional understanding of God in relation to time is that God knows the future. This has never been an easy doctrine to accept. How can God know the future, it is argued, when I, for one, have not yet made up my mind what I'm going to do next? What if the future in some sense does exist on an equal footing with the present? And I'm more concerned with the first part of that rather than the second part of that. And Arthur Peacock comments, if the future does not yet exist for God any more than it does for us, there's no question of God seeing ahead what the future is going to be, even though he can still have purposes to implement in that forthcoming future. I appreciate that a lot of this is going to be very difficult for you to remember, but you've got these quotes in your handout, and you've got them there for future reference. The idea that there are limits to God's knowledge of the future may come as a surprise, especially in the light of many arguments to the contrary in classical theology. This has implications both for what I will talk about tomorrow concerning the openness of the universe, in which God and we have freedom to be free agents, a freedom which allows the universe to be free to be itself. Then a quote from John Horton regarding the foreknowledge of Jesus. He says, as a human being, Jesus before his resurrection was clearly subject to the limitations of space and time. He possessed remarkable insights and hints that on occasion he had a clear view of future events, death, Peter's denial, other occasions when he expressed ignorance of the future or prayed for it to be changed. We Christians forget the humanity of Jesus at our peril. There is always a danger of trying to think of a spiritual Jesus, not someone of flesh and blood who shared our life and lived within the limitations of human existence. Back to John Polkinghorne again. I guess because I've met him many years ago and I've read most of what he's written, it's not surprising I'm using quite a lot of quotes from him. This is just a slightly more technical comment from him. Time is being assimilated to space, so the complete history of the universe is thought of as laid out on a four-dimensional space-time map for instant perusal by God. Space-time maps are chunks of frozen history. Now, I haven't been able to take you through what a space-time map is, but that's just a statement by a very distinguished physicist turned theologian who does understand relativity at that great depth. And another statement, there is no particular difficulty envisaging God as outside space and time, in some super dimensions if you wish to be prosaic in your imagining, looking down, that should be looking down, on the whole evolution of the universe laid out before him. Now, a lot of these I think are metaphysical statements or possibly even theological ones. They're not really scientific statements and yet they're couched in scientific terms. Before we conclude this particular discussion, there's one further matter we must consider. That is, how shall we understand the ordinary time we experience in the light of the counterintuitive ideas regarding space-time and relativity, the modification of time in the vicinity of a massive object, and so on? There is in fact a natural time to use in speaking of God's experience of creation. It is cosmic time, defined with respect to the overall structure of the world, that natural frame of reference that cosmologists use when speaking of the current age of the universe. And just to show that there's a consistency in what John Polkinghorne writes, he says in slightly different words, there's a natural frame of reference that cosmologists use when speaking of the age of the universe, cosmic time, provided by certain changing features of the whole universe. Hence, there is no incoherence stemming from relativity in our continuing to speak of God's experience of time in the created order rather than of times, meaning by the use of the singular, this cosmic time. That is, when we say the universe is 13.7 billion years old, we're using time in the everyday sense, and it is quite in order that we should do so. So what then is the extent to which theologians have built relativity into their worldview? I have some conclusions at the end, and I want to move on and just say something briefly about time and eternity. Pannenberg says, is there any positive relation conceivable of the concept of eternity to the spatio-temporal structure of the physical universe? It is unavoidable if the reality of God is to be related in a positive way to the mathematical structure of the spatio-temporal world of nature. So what he's saying is that we can't avoid thinking about space-time when we want to try and understand eternity. But I'd have to say that the connection to relativity is not that clear in that sort of statement. And this other statement, eternity has been interpreted traditionally as timelessness, but this contradicts the Christian hope for resurrection. Eternity certainly means unlimited presence. And finally, That's an extra quote from John Tulkinghorn. No, I don't want that one now. That's another slide. Mark Worthing from Adelaide, the biblical and Christian concept of eternity is not equivalent to those of classical philosophy or science, both of which have tended to limit the idea of eternity to an unending extension of space-time processes. And so I think what Pannenberg says about an eternal presence rather than endless time, I think is a helpful idea to as we look at this issue. But Bob Russell reminds us that the notion of eternity is actually quite complicated. Passing of time does apply. Two standard views of eternity, unending time or timelessness. God's time, which we call eternity, is more complex. Russell has also tried to construct an event world line flowing time picture, which I don't fully understand, that is a relationally based ontology of events in which the status of present, future and past is attributed to relations between events rather than to the events themselves. I couldn't find the reference that I had in my notes, but I hadn't noted the reference at the time. And then finally, the great symbol of the ascension of Christ is that in him humanity is taken into the divine nature. As part of that mystery, the eternal accepts the experience of temporality. All of this challenges us to consider the spatio-temporal aspects of events such as the ascension, and more particularly the fact that God has to interact within the space-time world and must therefore have a temporal aspect of his nature. But all these writers have struggled to find the words to tackle the issue of time and eternity, let alone to incorporate the scientific understanding of time and space-time. The quotations presented serve as a reminder of the difficulty of obtaining simple or even a single viewpoint at the present time. In conclusion, it is without doubt that relativity has withstood rigorous testing in the 20th century, and the implications of the linking of space-time and matter-energy into our modes of thought cannot be ignored either inside or outside of physics and cosmology. Is Peacock's 1990 observation still valid? Substantially yes, I suggest, because I do not see a consensus regarding embedding modern theology in the arena of space-time. Maybe it cannot be achieved. I admit it is difficult for many theologians without some background in mathematics and physics to properly incorporate relativity into their theology. Of course there's a risk for them. Yet, without achieving that, modern theology will be the poorer. My conclusions are, first, the weak impact. Relativity impacts theology whenever theologians refer to it intelligibly, and all the ones I've quoted, I think, have referred to it intelligibly. They did this within the limitations of their own knowledge and background. But I judge that in general, relativity has made little impact in a direct sense on what they have thought or written in most cases. Then the modest impact. Relativity impacts theology whenever there is reference to God, God and time, time and eternity, etc., in the context of space-time. I've reported a few examples that indicate how relativity may have impacted on our understanding of time and theology, something which Augustine grappled with so long ago. However, much of this discussion regarding God, God and time, and God's foreknowledge could, I suggest, have involved no reference to relativity at all. Most writers, after they mention space and time, tend to focus on God and time and leave space out of it. And then what I call an indirect impact. Relativity impacts theology, particularly whenever the primacy of general relativity and underpinning credible cosmological models is acknowledged. The overwhelming majority of authors that I consider accept that Big Bang cosmology provides the best picture of the processes that operate in the universe. In so doing, they recognise the central place occupied there by general relativity. Nevertheless, even when that was admitted, there was understandable and considerable reluctance to pin theology too closely to particular current scientific models. church history shows that when new paradigms begin to be adopted, there is often great controversy. Witness Galileo's difficulties as he embraced Copernican cosmology. It is my view that in due course, central ideas from relativity and modern cosmology will eventually find their way more universally into theology and philosophy, but it may yet take some time. I have a fourth conclusion, which I've debated whether to put in or not, but I think it's important. The linking of space-time, matter and energy in general relativity indicates how intimately we are all connected to the universe and its processes. As Dennis Alexander reminded us last night, I think John Bryant this morning, we're made from the stuff of burnt-out stars. That really shows how intimately we are related to the universe. Yes, we are embedded in nature. Were it not for a lengthy cosmic history, we would not be here because the necessary building blocks would not have had time to be made in second-generation stars. I've not actually found much discussion of this idea, and I think it's a field open for some further investigation. This adds something to what I think evolutionists have been telling us for a long time, how we're related to the rest of the living world. Relativity, coupled with quantum mechanics and modern field theories, continues to challenge our grasp of physical reality at the deepest level. We expect relativity to have something to say about time and eternity, important in Christian theology, and I look forward to seeing how it will unfold in the future. We should not be too distressed that there are not yet final answers. It will always be important to raise important questions, for that is one of the tasks of both good science and good theology. We should be grateful for the knowledge that we are privileged to have about our world, and this knowledge should inform our Christian walk and our prayers as we go on knowing and serving the God revealed in Jesus Christ. And thank you for your attention.
Thank you, John. I think we'll have 5 minutes of questions and then we'll have a short break before we have dinner tonight. But your mention of Bishop Tom Wright reminds me to say that you don't have to go to Sydney to hear him, because we're bringing him here on the 15th of May.
Yes, I noticed that.
5:30 p.m, Babbage Lecture Theatre in Cambridge, a public lecture. I commend that to you. I just think it'd be great.
I think I might have heard that public lecture.
Well, I don't know. You may not have, because it's kind of scientists believe the resurrection, so we've asked him to talk on science.
Is that what he talked about, Susan? I think it was, actually. But
well, that's really good then, because it's a title we gave him without knowing he'd done it before.
Well, something along those lines.
Anyway, I do commend that to you, because I think that would be great. But how about questions? Anybody want to ask anything of John? Yeah.
Here's a quick one. Quote from the screen: space-time maps are chunks of frozen history. I'm sure the word history is there deliberately. Do they have to be history? Is that because our time is an arrow?
Yes.
So it must be history.
Yes, that'd be the basis of that.
Okay.
I can check that with John Faulkner on Monday. Yes, John.
Can I ask, coming back to the question about language, I mean, that quote was interesting when John Faulkner says he doesn't see, he sees it, I think it was something like, it's very straightforward, or it's very clear what it would mean to talk about God looking down on the whole of space-time. But, well, I mean, from the standpoint of philosophy of language, I mean, that does, on face of it, look quite problematic in the sense that, in a straightforward sense, one looks down on objects, one doesn't look down on events. And also, of course, in a straightforward sense, if you're looking down on something, it's a present tense action. You're actually, in order to do that, you are within time. So, presumably, I don't know what, is his view then that it's straightforward if we think of God as temporal? Or is it his view, because
well, he doesn't, John Faulkner wouldn't argue that God is temporal, but he would say that there is a temporal aspect to God's nature. He'd want to stay well away from panentheism, because that creates difficulties when you think of the projected future of the universe, that that God would be diminished if our Earth disappears, as it will one day.
Sorry, I have a second question.
Should we just take one from the back and then we'll come back to
this might sound a bit silly, but I'm going to ask anyway. We've been looking at kind of how science reveals the mechanisms, as it were, that God uses. And all these mechanisms are used by him to serve his purpose. So we were thinking about how we've come as a result of all the evolution stages and the creation of the universe and all those sorts of things. And I was thinking that all those mechanisms so far have been revealable to us. We've been able to find out how they work, and then we've been able to use them ourselves and make choices about whether we should use them and how we should use them. I was just thinking that if we did crack time, and we could then hop around in time, it would then mean that we wouldn't learn by our mistakes anymore, because we could hop back and fix them. And with that, therefore, kind of destroy God's big plan. So is time difficult to understand, because if we cracked that one, it would kind of ruin everything.
I'm not sure that I can answer the question as you put it. I mean, it's a very interesting question. It's not a silly question, but I think it's a difficult question. But I think the sense in which, in spite of all the strange things that happen in space-time, that we don't have causes following events, means that I think we wouldn't get into that dilemma. Don't think we're going to escape our responsibility quite so easily. I think we will remain responsible for our actions as long as there is humanity living on this earth. I don't know whether that satisfactorily answers your question or not.
I think it's a good answer. I think another, and maybe an easy way to ask the question would be to say, do you think we will ever be able to move around in time? And with from a religious point of view,
going through a wormhole. I've heard Paul Davies give a lecture on that. I think it's a nice sort of intellectual exercise, but I mean, there are all sorts of practical problems in the way of it. You're not going to survive going through the wormhole anyway. You'll just be evaporated. But and as a thought experiment, yes, you can consider that. But and then there's the other issue in some models where you sort of go through the other side and come back to where you were. I don't fully comprehend that. I'm a humble spectroscopist, not another cosmologist.
It is already the case, though, isn't it, on current understanding that what happens right here now depends instantaneously now on the state of everything else in the universe. So there is some communication in that sense.
Yes.
I've still got you in mind, but there's two more at the back, and then we'll come back. Here first.
Okay. You said how various people had incorporated time and God, but you said they haven't really incorporated space as well, and I just wondered if you could expand a bit on how you think they might do that.
I'm not sure how they will do it. I mean, the issues in space-time become critical when you're near a very large object or a black hole or something, and none of us are going to be in that situation. So in terms of our own daily experience, we're not going to be faced with moving in a bent bit of space-time. So I think it is difficult, but when theologians latch onto the language of space-time, I think I have a reasonable expectation that they should try and say something just more than mention it, and then a little while later they're really only talking about time and referring back to Augustine. And I mean, Augustine came to his conclusions without knowing anything about relativity. And I think what disappointed me, and I did an awful lot of reading 2 years ago. I'm not sure how many books I read, but it was a great number. And I was looking for somebody who, even the former scientists, even like John Polkinghorne, who I thought might have developed that rather more. Of course, I'd have some recognition that the sort of theologians who come from a humanities background would not be immediately in a position to do that, perhaps. But, I mean, I think they take a risk. If a theologian talks about space-time and then basically moves on and talks about only time, I think that's a bit of a cop-out. And it's, in a sense, almost accepting a buzzword. It sounds good, but when you actually try and analyse what's been said, at the end of the day, you haven't really gone very far. That's my conclusion. I found that disappointing, but maybe I went in with the wrong sort of expectation. So all I've tried to do is just give you a bit of a bird's eye view of the sort of things that I think respectable people have said. Some are scientists, theologians, some are not. I think that they've, at some level, been credible, but haven't really gone the next step. That's my view.
I'm comforted that you used the word humble a minute ago. I'd like to join with that. I'm thinking about how this can be relevant in our daily faith, and I'm wondering if relationship is a word that we need to grasp hold of and make more out of. That the physics that you talked to us about emphasises that things are interconnected, that things and the environment that they exist in are all interconnected, that everything that a thing or event does affects something else and breaks down any sense that I am an island, that removes any sense that what I do won't affect my brother and vice versa. And I was fascinated by a little piece, and I don't know if it was intended, in one of the quotes that seems to say that God is allowing himself in eternity to be affected and changed and enhanced through relationship with us, and that may be a lesson that we can draw out of what you've been saying to us, and if that provokes something.
No, I think that's a very interesting argument, and I can look back on nearly 50 years as a Christian and think about the sort of things I used to hear in sermons then and the sort of things I read about today. And I would judge that there is now, even within quite conservative theological circles, a very different understanding of God and his relationship to the universe than I think was understood half a century ago. And I think that's very healthy. And I think it really opens up the whole issue of our relatedness as well as the relationship issue that you raised. And I think that's something that we need to sort of think through a bit more. I think it's really quite exciting that one can, there are people as clever than me have done this, can actually think about some of these things, even things like God's foreknowledge. Are there limits to that? By saying that, are we somehow imposing on God something that God, an aspect of God's character that's not true? Well, I think that probably isn't the case. We have minds, we have a sense of recognising logical absurdity, and so we can argue in a consistent way. We can also do something as human beings which I think is incredibly important. We can do what-if sorts of analysis. We can say, what if we assume this? What are the logical conclusions? Where does that take us? And sometimes you find it takes you to an absurd position, so you abandon it, you don't pursue that. And it doesn't mean that what I believe today, some of these sort of things I've talked about today, which are probably tentative, that they don't have to be the defining view as to my understanding of my relationship with God and so on. But I would say that our scientific understanding today must inform our understanding of the sort of processes that we're involved in. Tomorrow I'll be talking about how we might try and think about divine action, picking up some other issues. And I don't think it's inappropriate for us to have this kind of discussion. But we shouldn't embed it as dogma in our theological thinking either, until we've had time to sort of think it through carefully. That would be my only caution, I think.
I think we'll take one last question, and it's appropriate to start with a certain symmetry, isn't it? You the first and last question.
Thank you, the Alpha and the Omega. Just given that Jesus represents God submitting to his rules of the universe, does relativity, and at one point in your lecture I thought you are going to open the window to the possibility that God himself has entered through through our understanding of general relativity. We can allow God to enter fully the temporal world and yet maintain a viewpoint that is other than ours. Does your theology allow that, or is that completely?
I haven't thought that point through, but I think you're raising something that's very important. When we talk of God having a temporal aspect to his nature, I think, given what we know about relativity and space-time, it's somehow got to incorporate that element in it. But I've not seen anything written, or maybe Rodney has, I don't know. I've not seen anyone who's addressed that question, but I think it's a very good question.
On copyright.
John Taylor might have something.
John
to say
Taylor.
about it. Block universe and all that kind of thing you've worked on.
Yes, I mean, gosh, how much time have we got to talk about?
Yeah, quite.
Is that one of the questions?
So general relativity question, you can talk about it after dinner.
I don't think John is here after
Oh, you're not here?
I will.
Good stuff.
Oh, great stuff. Okay. Why do we do that? Because it is 10 to 7 and we will have dinner at 7. So please do take these question things and write them down maybe over the next 10 minutes or over dinner, talking to your people sitting around you. And we'll reconvene here at 8:30, I think it is, for discussion. So thank you again.